Hello guys, Hector here and welcome to base conversion. This is what the module will look like. There will be number, arrow number, a value in the middle, a third screen and a keyboard. And the idea of this module is simple. Convert from base A on the left to base B on the right. Not really much more I can explain, so let's get started with this. So, the numbers here are in order of their value, of course. And you can convert from the letters to their values by their alphabetical position, the alphabetical position plus 9. So, in this case we have 431 in base 19, which will be 19. You don't know how to convert the bases. The rightmost digit is the ones, then the next one to the left of it is the first power of the base, and the second power, and the third power, and so on and so on. So in this case, we have 4, 3, and 1. This one is 19 to the 0th power. This one will be 19 to the first power. And this one will be 19 to the second power. So in this case, 431 is 1502, and now we're going to convert that into base 13. And the way I do this is just subtracting powers of the other number off of it until you can't, up to the multiples of that value. So for base 13 it will be multiples up to 12th multiple. So you can have 12, 13 something, 13 to the something, but you can't have 13 turned into something because that would just be the next power up. So 13 to the third, does that go in there? No. The second does, and it's not going to go in more than once. But actually, it is going to go in more than once because the bottom number is just all we have left, not sorry. So we now see how many factors we can get into there. That's 8. So our first digit is 8. Subtract off the next power of 13, which is just 13 to the first. We can get 11 in there. So the second one is going to be 11 minus 9, which is B. And then finally minus 7. 8B7. And then we press the last screen. Okay, so module. Do be warned with this module, if you type in any wrong digit, it will strike you. So be warned of that. So up next we have base 19 again, actually. But this time to base 2, so it's going to probably be a few more digits. So we're starting with 19 squared, being the first digit. With its 3 digits, the furthest left one is going to be squared. And D is going to be 4 plus 9. Plus 19 times 5 plus 6. This is our D, our 5 and our 6. And now we're going to convert this number to base 2, or as you might know it, binary. So 2 to the 7th, 8, 9th, 10, 11, 12. 12 is the biggest one. So that's going to be a larger digit. And we can get it in there. Well, this is binary, we only focus on 1 or 0, so we actually don't need to do this bit. So minus 2 to the 11th, 10th, 9th. 9th, yeah, there we go. 9th is going to be the one we're going for. Minus 2 to the 8th, 7th, 2 to the 7th, minus 2 to the 6th, 5th, then minus 2 to the 4th, that works, minus 2 to the 3rd, yes, minus 2 to the, just because it's a not to 1, and then we have 0. So, now looking at this, we now figure out what this is represented as. So, that this would be 1. Let's do this, let's, just so we know we're getting it right. 6, 5, 4, 3, 2, 1, 0. And we have 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 0. So that should be our number. We can quickly double check that. I would suggest always using this for this one because it might ruin the fun for some people. But let's check here. And yes, this is what we get. So now typing this into the module. Okay. 1, 0, 0, 1. 0, 1, 0, 1. 1, 1, 0, 1, 0. Submit. And the final one. Base 31 to base 23. So we have 4 times 31 squared. Again, 3 digits, leftmost 1 is digits minus 1, so squared, or 2, power of 2, plus n, which is going to be 14 plus 9 times 31, plus just 15 plus 9, which is O. Oh, that's a 0. I think that might be a 0 actually. It might actually be a 0. What do we have before that? I think it might be a 0. Oh, it's actually quite hard to tell these apart, but it looks more like a 0, I think. If I get a strike, I'll just rework it out with the 15 plus 9 instead. So we now have this. And we're now going to figure out what this is in base 23. So 23 squared. Third. So this is squared. And then how many 23 squares can we get into there? 3, 4, 5, 6, 7, 8, 9. 8 we can get into it. Minus 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14. Minus 3. 14 minus 9 is 5. This is 8E3. So hopefully, if we've done this right, we get this, and we get there's a module. Sorry for that little kerfuffle in there. But that was base conversion. Quite a simple module, just test your base conversion. Reminder, there is a mod setting that you can use to change the values that you can use for this for this module. It starts out, I think it's like 2, 4, 6, 8, 12, 16 to base 10, but you can add all the other values in from 2 to 36. Well, that's the ones it supports at the moment. So, that was base conversion. Hopefully this module makes a bit more sense now. and I see you guys in next tutorial. I see you later.